How can you measure voltage with just two resistors? So as shown in the circuit, we have resistor 1, resistor 2, our voltmeter or multimeter, and our voltage source, which is in this case a battery, with the value for R1 and R2 given, which is 10k each. And if we now assume that the voltage from the battery is, let's say, 5 volts. So we have 5 volts here and 0 volts here, because that's the minus pole of the battery. To measure now the voltage, or to calculate it, there's a rather easy formula called voltage divider. And this is as follows. UG, so the overall voltage, multiplied by R1 divided by R Gesamt, or R general, so the resistance of those two resistors in series. The overall resistance is calculated by just adding the two resistance, so 10k plus 10k equals to 20 kilo ohms. And as we know that the given voltage is 5 volts, as we said, we have 5 volts multiplied by 10 kilo ohms divided by 20 kilo ohms, which gives us a voltage of 2.5 volts, and that would be the voltage that we measured at this point here with our voltmeter, with the plus probe here and the minus probe here at ground or battery minus. So right here I have a resistance voltage divider from 47 kilo ohm resistors with the plus probe in the middle from the multimeter. The voltage is set to 5 volts on the power supply on the right side, and if I now connect it, we're gonna see 2.5 volts shown on the multimeter. Now we have the positive connected and the negative, as well as the multimeter and ground to the ground of the power supply. If you now turn the supply on, we can measure a voltage of 2.487 volts. So let's say 2.5 volts, which is as you know. So we can say that this setup divides the voltage. If you now crank up the voltage to, let's say, 10 volts, we get a reading of around 5 volts. And we can do that with every single voltage we're on, let's say 30 volts. We should get around 15 volts, and right there you can see it, almost 15 volts. The difference comes down to the power supply not being calibrated, as well as not the multimeter not being calibrated, so that's completely normal. There's some small differences in the voltages that you measure. But what use has a voltage divider in the case of high voltage? So for some applications we need a rough number of the voltages, for example for building voltage doublers or Tesla coils. And you can't measure like 10 or 15,000 volts with normal multimeters. They just go to around 600 to 1000 volts and would fry the fuse or get completely destroyed if you would apply such a high voltage. So the device you see in front of you is a big DIY voltage divider, which divides the voltage by 1000. So 1 volt measured across the resistor inside is equal to 1000 volts. We have one terminal on this side and another on this side. So this is, let's say, the one side of the overall resistor, and this is the other side right here. So you would connect the load via the two blue wires. And then you have two black wires going out of the one side. Those are for measurement. They go to a 10 kilo ohm resistor, and the overall resistance of this build is 1,010,000 ohm. So I've just built a big 10 mega ohm resistor out of several small 1 mega ohm resistors, which are those here. This one, for example, it's a 5 watt 1 mega ohm resistor, and I choose them for the simple factor of their size. So the voltage has to be really high to jump across those resistors. So I had hooked up 10 in series to get 10 mega ohms, and then I just used 10 kilo ohm resistor afterwards to get the voltage divider. So it divides by the factor 1000. So right now I'm measuring the voltage above the previous shown voltage divider. As you can see, we have a voltage of 6 volts or 5 volts on the power supply, and we're measuring 0.0047 to 48 volts. So 4.7 or 48 millivolts. As you can see, it's divided by the factor 1,000. If we would now crank up the voltage to 10 volts, we should get around 10 millivolts, or in this case 9.3, because the resistors are not exact. But it's okay, because in most high voltage applications we don't need that exact measurement, so we don't need it to be exact, because you always want to build with some headroom, because an unloaded transformer has a higher voltage than an unloaded transformer, for example. So you don't have one fixed voltage. If we now would, let's say, use 30 volts again, just to showcase it, we get a measurement of 0.28 volts. So 228 millivolts. It's off by 2 millivolts, but that's, as I previously said, it's okay. It's not perfect, but it will work for 90% of the applications you're gonna use something like that. Yes, so that's about it. If you have any questions, please ask me now.